Good evening, all. Good evening. You're welcome to the tutorials with From Eternity the Schoolboy. Today we'll take a look at physics. We'll review our physics assignments. Physics review assignment 6. The question says, which of the following is the dimension of pressure? A, m per L per T squared. B, ml per T squared. C, ml squared per T cube. D, m per L cube. What's the answer? Come and show us the answer on the board.
So that thing is in our thought really confused me.
You say what?
I went and do another thing.
What did you do? Hey. How come? Don't you read the? Read the what is it called? The post well. Chiwen, to come and solve it on the board fast. Fast. No time to waste. Okay, let's see what you did. What did you do? What did the question say? Okay. You don't do this things again now. Since they have mentioned pressure, just go straight to pressure. Get the formula for pressure, break it down to the units. Then you now do what? Get the one dimension straight. And look at the one that suits that is the center of the units.
Like this last
Yeah, now. They have already said pressure. So you don't need trying to look at all the converting all these. They are already within this one side dimension already. No need. You only just change pressure. Get the pressure, the dimension of pressure, and compare it with the what? Option. Simple. So what's the answer now? It's a don't waste your time trying to do all this. It's good you do it, but it's not. This question doesn't need all this long thing. Am I communicating? The question is simple. Which of the following is what? Dimension for what? Pressure. And pressure is what? Force per unit what? Area. That is force over what? Area. And that's what she did. That pressure is what? Force over what? Area. So if pressure is force over area, then you go down to force. Force is what? Newton, which is actually mass times what? Acceleration. Yeah, then you get the SI unit of mass, which is what? Kilogram, right? Then SI unit of what? Acceleration, which is what? Meter what? Per second square. All over what? Area. Unit for area is what? Meter square. True of us? Meter what? Square. If that is the case now, one area will cancel one area, right? So we are left with what? Kilogram per second square over what? M. Using law of indices, this M will come up. It becomes kilogram per meter per what? Second square. This is the what? This is the what? The units for what? Pressure. If you break it down by the component what? Unit. This is what you will get. So what I'm going to do now, you convert this to what? To what? Their dimension. So the dimension here now is what? This is how to represent it. Pressure is actually this. If you put it like this, it means that this means what? The dimension, okay? Dimension for pressure is now what? This kilogram will now change to what? Capital what? M. This per meter will now change to capital what? L. And per second square will change to capital what? T. T is power minus 2. This is dimension for what? Pressure. And having done that, just go to the options and check the option that what? Has this. And that option is what? Is what? Chineye did biology. Ada, is that what you got? Is that what you got?
But the answer is A.
Is that what you got? So if you travel, you know the assignments.
No, my phone
This
was
thing
down.
is now being sent on WhatsApp. So anyway, you do your thing.
My phone was
You
down now.
why? You don't see it where? I don't understand what is going on. You check your mommy and your dad, they're in that group. You check your mom's WhatsApp, it's not there. You check your dad, it's not there. Oh, wow. Is that what you got?
I did the assignment, but I didn't do number 1.
But have you seen it now? Mr. Omar, is that what you got? As your answer. You solved it, right? Okay. All right, so let's go to number 2. Okay, any question? Ask. But have you taken the correction now?
Yes.
Good. That's the most important thing. To take the correction and move on. Then number 2 says, in order to remove the error of parallax when taking measurements with a meter rule, the eye should be focused A. Slantly towards the left of the markings. B. Slantly towards the right on the markings. C. Vertically downwards on the markings. D. Vertically upwards on the markings. I don't know what's the answer. Okay. What's the answer? C? C is what? Is that what? Did anybody get any contrary answer? What did you get, Michael? D. D is what? Vertically upward. How? Explain. Explain what you mean vertically upwards.
When you're reading an object, you keep your eye level on top of the reading while reading the object.
You read. If you say you are reading vertically upwards, see what you are reading. You read like this. Look at it on the marking. You are looking at it because you have.
That's what this means. I thought that was what it means.
No. You are the one taking measurement. So your eye should be here, vertically, downwards on the marking, not by the side, or upward. Is here. Is it clear now? You clear now, right? Good, thank you. So the answer is what? C. I know why I said try as much as possible not to make the mistake of not copying these things in your notes. Any of them, copy it in your notes. Do it in your note. It's very important. At the end towards your exam, if you bring up the distance we are doing here, small, and go through it, that's when you realize how rich what we are doing here is. That time, all you need to do is just be flipping through them because you have solved them yourself, taking the corrections for those that you failed, and as we are going through it, you can go through what you're doing here for over 1 year, under 1 week. You can go through it and go for your exam. That's why I want you to be copying it. Don't make a mistake of not copying. If you come here and answer it and go, you're not helping yourself. Make sure you copy it. It's very important for your final revision. All right, let's continue. So the answer is what? C. Vertically downwards on the what? The markings. Number 3. Which of the following is not a vector quantity? A. Altitude. B. Weight. C. Displacement. D. Acceleration. A is what? Altitude. Altitude is a measure of what? It's height, right? So it's distance, right? It's not a vector. It's a scalar what? Quantity. But others are what? Vector quantities. Thank you. Number 4. Did anybody get a contrary answer? Please, if we answer a question and you got a contrary answer, don't keep quiet. Say it that you got a contrary answer and your reason for that your answer. From there, you will learn something what you probably did not know about it. Don't keep quiet or hide. Number 4 says a body of mass 5 kilograms initially at rest is acted upon by 2 mutually perpendicular forces, 12 Newton and 5 Newton, as shown in the figure below. You must have drawn it for those that have seen the assignment. If the particle moves in the direction QA, calculate the magnitude of the what? Acceleration. Calculate the magnitude of the what? Acceleration. Who solved it? Who solved it? What did you get? So what did you do? Tell us how you solved it. Let's learn from you.
I enclose the diagram, then find the resultant force 12 squared plus 5 squared 169, then square root of 169 13. Resultant force is same as mass times acceleration. Then I did 13 1 to the force, which is 5 Newton. I mean 5 kg.
The force or mass?
Mass, which is 5 kg, times the acceleration, which is 1.2. Then 39 times, I got 2.60 Newton per square.
Who did not understand what she said now? Okay, no, well, let me solve it. Look up. The question says, actually, this is the diagram. The question says, the diagram is like this. Like this. Please, while drawing vectors, try as much as possible to represent the magnitude of the vectors in line with the sides of the triangle, whatever you are using. You cannot say, if here is 5 Newton, make sure that this, even if it's not exactly to scale, make sure that this 5 Newton is less than half of what? 12 Newton. See what I mean? You know, here is 12 Newton. Here is 12 what? Newton. And here is what? 5 Newton. You cannot say you are representing a vector and you come here and put this small line here to be 12 Newton. Is wrong. Okay? Just try as much as possible to do that. So here is what? 5 what? Newton. Now, and the line for the resultant distance goes like this, something somewhere here. It's understandable because this is resultant, and it will definitely take the direction of the what? Of the what? Of the what? The bigger what? Force. True of force is normal. So now with this now, we are told to find the what? Resultant. If you extrapolate here now, it will end here. If you extrapolate here now, it will end here and enclose it as a what? As a what? Rectangle, right? Now, look at this now. This is the resultant. This is R is the what? Resultant. And we need to find this resultant using Pythagoras what? Theorem. Using what? Pythagoras what? Theorem. So you have that R squared is equal to what? Hope you know that here is something with here. Hope you know. And here is something with here. Hope you know. R squared is now what? 12 squared. 12 squared plus what? Plus what? 5 squared, which is what? 12 squared is 144. Plus 25, which is now 160 what? 9 Newton. 169 Newton squared. So R is now square root of what? 169, which is what? 13 what? Newton. This is the resultant force. These two forces are acting, but the one that will cause the movement is the resultant what? Force, the effective force. The effective force is what? 13 Newton. And that is the force we are going to use in the calculation. Remember that force is equal to what? M what? A. Mass times what? Acceleration. It's the force that we need to act is the effective force that will cause the movement. So F, we are getting the effective force to be what? 13 what? Newton. So 13 is equal to, the mass was given as what? 5 kilograms. So we have 5 what? Kilogram times what? Acceleration, which is A, right? So A is now equal to what? 13 over what? 5, which is what? 2 point what? 2 point what? So 2.6 what? Meter what? Per second square. This is acceleration. This is what? Acceleration. So the answer is what? D. The answer is what? D. Any question? Any question on this? If you are, please ask. This is review. We don't rush our review. We take time to do what? Understand these things.
It's not that I want to verify something.
Okay.
Your inclusion is your inclusion now. This is like this. And
Like-
you solve it like this.
Like how? I didn't get what you say. You say what?
Your enclosure now, you close it. You know, if you want to solve a vector, you have to close it first so that you'll be able to work it out. I'm not asking, I'm now trying to say that, okay, your enclosure is like this.
I don't understand your question. Communicate to a let me understand what you're saying.
Now say it. You solve this like this now.
It doesn't matter where you solve it.
I'm just, can you also solve?
Yes, no, yes, it doesn't matter. If you want, look up. If you want, face this side. It's something. Hold on. It's something. It's something. Even if you face here, you say what? R is R square is 12 square plus 5 square. If you face this side, R square is say what? 5 square plus what? 12 square. This thing is a two equal triangles lying like this. True of us. It's two equal triangles. Okay? Any question?
You know that we are going to solve this thing with Pythagorean theorem. Why the need of including it again?
You don't understand. See, this thing. If you watch, you have extrapolation to tell you what it has formed. Okay? Even if you don't do it, once you understand the geometry, you have no issue. Number 5 says, two cars moving in the same direction have speeds of 10 km per hour and 100 km per hour and 130 km per hour. Full stop. What is the velocity of the faster car as measured by an observer in the slower car? What is the velocity of the faster car as measured by an observer in the slower car? A. 130 km per hour. B. 230 km per hour. C. 200 km per hour. D. 30 kilometers per hour. What's the answer? Are you copying the answer? How do you now handle your case now? All the time I was saying assignment, you say you don't see the assignment. What's going on? But the last assignment I posted, you had that one day and put emoji that liked it. How come he did not see what he liked? I don't understand. The last one, even that one you say you did not see. You had that went there and liked it. So how come he saw it? Can't say I don't understand. Explain that. You say your dad. You didn't ask your dad to help you get this thing that you didn't ask him anything. Did you ask him? He said he didn't see it. What he liked. I don't understand. Don't worry. I will speak to him myself. Let me understand what he's doing. I'll speak to him. No one. Okay? I'll call him after this class. I'll call him. Because that is the only way. Because if you keep copying that note on the board here, sorry. Before you will finish copying it, 30 minutes will go. And it's not helping issue. So who knows the answer? With reason, explanation. Explain now. What do you have idea? As if you don't know it.
The answer is 30 kilometers per hour.
Explain.
Use the speed of the 130 kilometers per hour. Then I minus it from the 100 kilometers.
So why did you minus it?
Because say what is the velocity of the faster car as measured by an observer in the slower way. The faster car can have sneak.
I will know.
Yes, it's 130. Then you minus 100 from that
Hey, Ifolonya, Omalia. Who knows it? Who knows it? Speak. You know it, right, Miss Someone? No. That is not enough. Ada, Oya, tell us. Oya now.
Yeah.
Where is success? Chiwendo, Oya, help us. Oya now. All right, listen. This is what is. I think I mentioned this in our last time. Relative what? Motion. Relative what? Motion. Remember I told you that I gave an instance in our last class that if somebody is if you are in a vehicle, if you're in a vehicle and you are sitting down in a vehicle and the vehicle is moving with a particular speed, if the vehicle is moving at the speed of 100 kilometers per hour, you yourself are also doing what? You are moving at the determined what? Speed. You know why? Because there's no relative motion between you and the what? The car. Your velocity is same with the velocity of the car. But if you are going back or if you are coming forward, the speed is not what? The same thing again. But there's a relative motion between you and the what? And the car. Am I communicating? Now, if let's assume you go back in opposite direction with the velocity of, let's say, 5 kilometers, for example, now per hour, and the vehicle is moving with a what? With a velocity of what? 100 what? Kilometer what? Per hour. You are not moving with that same what? Velocity. Are you with me? Now, if you are in a car and the car is moving with 100, let's say, as the question stipulates, speed of 100 kilometers per hour, and a faster car is moving with at speed of 130 kilometers per hour. The one you are inside sitting with is moving with what? 100 kilometers. The one that is faster than the one you are is moving with what? 130 kilometer. If you are in that your car, because your car is moving with 100 kilometer, and you are watching that car in front of you, the speed to you, the speed the car will moving is not at 130, because you are moving with what? 100. So the speed the car will moving is what? The difference between that car and your what? And your own is what? 130 what? And see what? 30 what? Kilometer what? Per hour. Because the one you are moving has taken 100 from that, the one the car is moving with. The one you are, because your own speed are taking 100 has taken 100 kilometer per hour, which is the speed you are moving with. But had it been you are just one place, sitting down in a place, you are not moving, you are just sitting down, and the vehicle is moving. What we've seen is that speed of, if at all you can read it with your eyes, is 130 kilometers at your speed, because you are not moving with any what speed, you are just staying one stationary. Does it make sense? So that's actually the explanation. This is what you see in what? Relative what? Motion. Relative what? Motion. So the answer is actually what? D.
Question now. This thing is not mentioned. I'm not saying that you are wrong. I'm just trying to tell you what the reason why I cannot explain this thing. Because I did not see the relative this thing or uniform, something like uniform velocity now.
It must not be mentioned.
It will not be mentioned. Then okay.
It must not be mentioned. Okay? All right, let's continue. Number 6 says, the effective potential energy E of a lunar satellite of mass M1 moving in an elliptical orbit around the moon of mass M2 is given by E is equal to K squared over 2m1 r squared minus g m1 m2 over r, where r is the distance of the satellite from the moon and g is the universal gravitational constant of dimensions m per m l cubed per t squared. Determine the dimensions of the angular momentum k of the satellite using dimensional analysis. Who solved this question? Who solved it? Nobody. Who solved it? Come on. Or who want to try? Come and try. It's simple, it's not difficult. You just for it to be, but you need to be careful in solving, so you don't carry where M and put where L should be. Just once you are careful in organizing your this thing, knowing the dimension that belongs to each unit, at the same time knowing your law of indices very well. If you know your law of indices very well, and you know the dimension that belongs to each of the units, then and know how to collect items. These three things, you can solve the question. So who solved it? Mesoma, what do you get? Michael, what do you get? Do you solve it? Can you have run the question? Ada, you solve it.
I solved, but I cannot explain. I solved it.
Let me see where I solved it. Don't explain. Let me just see where I solved it. Where did you solve it? I see where you solved it.
See it now.
Where you solved it.
So a solution. Okay, I'm not with the notebook yet. But 6 now, but I'm not with this thing yet.
Okay, Ada did not solve it. So who solved it? Nobody. Wow. Maybe an assignment. Let me be sincere with you. If you truly do these assignments from now till the end. On a more serious note, you have covered what you should cover. You have covered what you should cover. In any exam you are writing, whether you are writing WAEC or whether you want to write JAMB, anyone you want to write, you've covered. I don't know why. What is taking your time? I don't know. I don't know what is taking your time. Anything taking your time now is a distraction. Because that thing can wait. For it. It can wait. No matter what that thing is, it can wait. All right, let's look at the question again. The question says, we are given a formula. We say the formula is E. Hope you can see the board, right? The formula is E is equal to K square over what? 2m1 r what? Square minus what? gm1 m2 over what? R. Now, we are told that this is the electrical potential what? Energy. And this is what we are asked to do what? Find, okay? We are told to find the dimension of this K. And this K is the angular what? Momentum. Don't forget about all this long grammar. Your own is to make K the subject of the what? Formula and find dimension. Simple. So how do we go about it? So the first thing is to make this K the subject of the formula. So basically K square over what? 2m1 r squared is equal to what? E. This term to this side becomes what? Plus what? gm1 m2 over what? R. That's the first step. Then you continue. Our target is to make K the subject of the formula. So we cross multiply. We have that K is now equal to what? This, we multiply this. We have what? 2 what? m1 r what? Square times what? E plus gm m1 m2 over what? R. Is it clear? What I did now, is it clear? Huh? Huh? Sorry, it's still square. Is it clear? The step I took now, is it clear? Now let's continue. So we now have something like this, that K is now equal to what? Square root of everything here. 2m1 r squared bracket what? E plus what? gm1 m2 over what? R. But what we want, we were looking for the dimension. Remember, in the dimension, any constant here that doesn't have unit will do what? Go. Hope you know. In dimension. Like 2 now, 2 is a constant, 2 has no unit, so it's dimensionless. It will go. Any coefficient here that has no dimension, no unit will do what? Disappear. Because they are now dimensionless what? Constant. This is a constant, hope you know. And this is a constant, but they have what? Units. So they will not go. But things like 2, 3, 4, or any number that appear in this thing now will do what? Go. Now let's continue. So the next thing now to do is this. Remember our law of indices. In our law of indices, this is certain as saying, K is certain as saying 2m1 r squared E plus gm1 m2 over what? R. Everything what? Good. So at this point now, let us open this bracket. Okay? Let's open this what? Bracket and see what we can do with it. If we want, before we open the bracket, if we want to, we can resolve this to get, we can resolve this to be like this. That K is equal to what? 2m1 r squared E plus LCM here will be r. Hope you know. Hope you know.
Yes.
R divided by 1 is what? Times E is what? ER plus what? GM1 M2 all what? Half. Everything is inside this half. So this can actually go. Hope you know. We have one area. Are you aware? So we can now get that K is equal to what? 2m1 r E what? R plus what? GM1 M2 all what? Half. You don't understand what? Look at R here. They will cancel. Yes, now because R had to come here. This is set now saying is that not what we got? How do you do your LCM? If you have 1 plus 2, 1 plus 1 over 2, what do you do? Tell me what to do. I'll do what? Multiply what by 1? No, tell me step by step what I should do. Do what again? Multiply 2 by 1 and write it where? Here, and do what again? Here. And got what? Oh yeah. Do this one. E plus 1 plus G M1 M2 over what? R. Oh yeah. Let's go. I'll do what again?
Multiply E by R.
Tell me now.
Multiply R by GM1.
Is it something? So what is the difference between what that and what I did here? No, I cannot be again because there's R here. This thing will divide this. What actually happened is that 1 divide R is R. R times E R is. This divide R is 1. 1 times this is. That's what we did here. 2. 2 here. This divide this is what? 1 divide what? 2 divided by 1 is what? 2 times 2 1 is what? 2. 2 divided by 2 is what? 2. 1 times 1 is 1. That's actually what happened, basically. Okay? Are you okay now? Good. Now let's continue. So, having arrived at this point, the next thing we'll do is that we'll now, if we like, we can still maintain our half here to avoid confusion, and now go straight to the. Let's break down the unit of component of all these components first. The one that we have not broke down the unit is what? E. Is electrical potential what? Energy. And energy is measured in what? Joule, right? Right? Joule. And if you break down joule is basically what? Force times what? Distance, right? Work, right? Good. And force is actually Newton, right? And Newton is actually what? It's actually what? Mass, what? And what? Acceleration, right? Times what? This is Joule, hope you know. Mad. True of us. That Joule. Joule is what? Mad. Mass, acceleration, and what? Distance. True of us. Now let's now carry mad and replace this E. Let's carry mad and do what? Replace this what? E. So if you carry mad and replace E, we have something like this. K is equal to what? 2m1r mad, okay, r plus what? gm1 m what? 2. Everything is say what? Half. Now at this point now, they only gave us dimension for this g. So we will use the dimension when we come down to what? Dimension. We are resolving the what? The quantities. So now there's no other quantity now we have not resolved. So let's go down to the unit of this what? Quantities. So 2 is now equal to what? 2 what? If we want, we can open this bracket first though, before we go to the units. I think it's better said. Let me do it. We have what? 2m, whether is m1, m2, m is what? M. So 2mr times mad, we have what? We have what? 2m what? Square, right? What? A what? ADR what? Square, right? Good. Plus what? This times this, we have what? Good. 2 what? M what? Cube, R, and what? G. Thank you. Thank you. So K is what? 2, this open it bracket, we have what? 2m squared, A what? dr squared plus what? 2m what? Cube, then R what? G. Thank you. So we have what? All is power what? Half. Now, at this point now, what do you think we can do now? Let us now go down to this is in what? R. Okay? This R, they are still in their what? The symbol of their distance. So let's go down to what? Units. If we have K is now equal to what? 2 what? Kilogram what? Kilogram what? Squared, right? Then this A is what? Acceleration, right? Meter per second squared. D is what? Distance, which is what? Meter. R is also what? Which is also meter, right? So this is M what? Yes. Meter is M what? Cube. Good. Then plus 2 what? M cube. In fact, R is also what? So this is not, this is kilogram, sorry. Kilogram what? Cube. R what? R is meter, right? Meter what? Simple meters. Then what? G. Are you with me? Any confusion here? No confusion. Now, we have taken this down to what? Their units. Let's go down to their dimension now. So, this K will now change. We put a symbol for what? Dimension. The K will change, okay? Now, if you want to now go to this dimension, every other dimensionless constant will do what? Disappear. 2 will do what? Go. And if 2 goes, K kilogram square will change to what? Capital what? M what? Squared. This L will change to what? This M meter will change to what? L. Per second square will change to what? Capital what? T squared. This one will change to what? L what? Cube, right? Plus, of course, 2 will go. Kilogram will change. This kilogram will change to what? Capital M cube. Meter will change to what? Remember we are given the dimension for G, which is what? Check that question. Okay, it's here. Dimension for G we are given is what? Let's now put dimension for G as what? M what? The per M. L what? Cube per what? Per T square. All in what? Raised power what? Half. Now, let us now collect the bases that are what? The same. And take it off from there. Here now, the operation here is plus, so this cannot cross. Let's solve this separately and solve this what? Separately. Now, let's go. We have, where I have plus. You cannot cancel out. Just calm down. You see what I'm doing. Watch out. Here, m squared, only one m squared is here, right? Here is L is here, right? We have what? L what? 1 plus 3, right? We have what? 4. This one is T what? Per square. Plus, here is what? M is here, right? 3 minus 1 is what? 2, right? Good. We have L what? L what? L4, right? L is equal to 4, right? And what? T square. All in what? Is equal to half. Now, are they same thing now? So you can have this thing. 2 what? But remember, in dimension, there's no constant, right? Hope you know. Are you aware? Constant doesn't work there. It has no dimension. So this 2 is as good as what? Gone. Hope you know. You just pick only one of it. Are you aware? So if you pick only one of it, we have what? M what squared L what? T minus 3 square minus 2. All what? Half. So we can now comfortably open this bracket. If you open it now, half will multiply all the powers. So you have 2 times half is what? Just like 2 times 1 over 2 is what? 1, right? So this is what? M. Then 4 times 1 over half is what? 1 over 2 is what? 2. We have what? L what? Squared. Then T, we have minus 2 here as the power, right? Minus 2 times 1 over 2 is what? Minus 1. So you have ML squared per what? T. So the dimension for K is equal to what? ML squared per what? Per what? ML squared per what? T. This is the dimension for the K, that is the angular what? Momentum. That's the dimension. Once you know how to align your distance, this is a theory question. Is a theory question. It's an answer question. Once you know how to align for those that are preparing for WAEC, please align your distance well. Hope you notice the mistakes I was making. So this calls for you for carefulness in writing. You can still fail what you know if you're not careful in do what? Writing it down. So take it step by step. Don't rush it. Try to organize yourself well and write it well, and you will get your full mark. Once you know your law of indices well, you know how to collect like terms, how to change. I apply for 4 scales here. One is how to do what? Subject of what? Formula. Change what? Subject of what? Formula. The second one is you are what? Laws of what? Indices. And the third one is your what? Collection of what? Like terms. And know your units. Know your unit, know your quantities, their symbol, their units, and their dimension of the units. Once you know all these things, you can solve this question. So have you not seen how I can apply this thing? A lot of things are involved. If you're lacking in mathematics, you cannot solve it. True of us, you can't solve it. All right, let's look at the next question. The question says, which of the following physical quantities is correctly paired with its corresponding SI unit. A, density in bracket kilogram meter cube. B, power in bracket joule per second. C, specific latent heat in bracket joule per kilogram per Kelvin. D, pressure in bracket Newton per meter. What's the answer? What's the answer? Huh? B. Okay, why not A? Density.
A is kilogram per meter cube.
Meaning by formula. What does it mean by formula? What does it imply by formula?
First, over kilogram.
Density. Mass over what? Thank you. Mass over what? Volume. So density is mass over volume, but they're telling us mass times volume. Can you see it now? So that's why it's wrong. What of C? C is what? Specific latent heat. We describe latent heat here when we talked about change of state. Okay, when you heat a substance, it change from solid. Latent heat of fusion is needed to break down the intermolecular what? Forces, right? That held the solid particles so that they can be converted to what? To what? Liquid, right? So now that latent heat, now that space, when you see latent heat, just talking about the quantity of heat. But when you say specific latent heat, then that means we are not talking about the heat per unit what? Mass. So, but actually, from definition, specific latent heat is actually what? Is actually what? The quantity of heat divided by the what? By the mass of the what? Substance. Okay. So it's actually joule per what? Joule per what? Kilogram. Because the temperature is what? Constant. The temperature is what? Constant. So there's no temperature there in the what? It's just joule per what? Kilogram. But here they told us what? Joule per kilogram per what? Kelvin, to confuse you. That's why it's not the answer. Then pressure, as Chinwe did here, is what? Force per unit what? Area. But they're telling us now, they're saying that is force over distance, which is wrong. True of us. So that's why that one is not correct. So the answer is actually what? B. Power is work done. The rate of what? The rate of what? Doing work, right? Which is work over time. Joule per what? Second. So the answer is what? B. Thank you. Number 8. You have the diagram, so I wouldn't want to waste our time drawing the diagram on the board again. So don't waste time. If you don't have it, go close to your neighbor and look at the diagram on his or her book. Let's go. The question says, in the diagram below, the diagram below represents a portion of a micrometer screw gauge in which the horizontal scale is in what? Millimeters, mm. What is the reading on the what? Instruments. What's the answer? D. How is it D? Explain. Why do you say D? Just say it. Just say it. You don't write anymore. Just say it. If you know it, you know. Just say it.
No, sir, you just check the division.
You check what?
Divisions.
Division, okay.
Then you multiply it by 0.01 millimeter.
You multiply by what?
Least possible.
Where did you take it? There are two divisions there now. The division, is it in the Vernier scale or the main scale?
The Vernier.
Okay. You multiply by what?
0.01.
Millimeter. I agree with you. I have what next?
Then you now count the Vernier scale.
Okay. Vernier or main scale? Which one has?
The main scale.
Okay.
Now check how many divisions there.
Okay.
Then you now add it
Okay.
to the answer and you got complete.
So what did you get? In each of them, what do you get in each of them?
Okay, in the Vernier scale, like
I got 0.22 millimeter. Then in the main scale, I got 3.22.
The confusion is what? How can you get 3.22 in the main scale and got 0.22 in the venial scale? And the answer is what did you get from the main scale?
In 3.
3 what?
3 millimeter.
We've done this over and over again. Which one do you get? Which answer do you get? You were not? Wow. How many times have I talked about this in the class? How many times? How many times? My oh man. And our time is going. This is one of the first topics we did in this class, or second topic itself. And every review, it comes out. If it comes out, I'll end up being one to answer it on the board. Let's make a change now. After answering it on the board, I'll give it again as assignment. I'll end up answering it again. It doesn't show improvement to at all. And after that, I'll ask a question. Do you understand it? You say yes. Chiwada tried. You still have some. You didn't present your work well, even though you got the answer. But you didn't present it because that's how the question can be twisted. If you don't have a strong understanding or deep understanding of it, you make mistakes. That's why it's good to get. You should answer that question. You were there when to take it. All right, Lord, it's just that I see drawing this as a waste of time because you already have it and there, but there's no icon. Okay, just look at your work. Let me draw it again. Look at your. Did you draw it in your book? Go to somebody that has it in now. Scan see and see what you are doing. Look at somebody's work and see what you are doing. Now, if you look at this thing now, this horizontal side is what? The main scale, okay? From here, from this point here is the what? The vernier, okay? Now, actually, what happens is this. This main scale, this is calibrated in what? Millimeter, normal. So, you check the reading in the main scale, check the reading in the what? Vernier scale. But the reading in the main scale stop where the vernier scale starts, okay? Now, before you now know the corresponding vernier scale, there must be a coincidence. Check where the main scale, this scale of the main scale coincides with these divisions of the what? Vernier what? Scale. That is, will show you that is where you read off that in the what? Vernier, in the vernier scale. Now, for this micrometer screw gauge, each of these division, each of them, look at this subdivision. Each of this division, each of them actually represents 0 point what? 0 point what? 0 watt. 1 0 point what? 0.01 watt millimeter. Now, if you did this number you see attached there means number of division, not the value of the what? Division. This thing you are seeing 15, 20, 25, 30 is the number given to there is the 25th division. So if you stop at 25th division, to know the value, multiply it by the value of 1 watt division, okay? If you multiply it now, you get the reading in the what? Vernier watt scale. But before you do that, check where this main scale coincide with the what? Vernier scale. If you trace this in properly, this line at the middle, trace it to this place, you will realize that if here is 20, if you go up, you find out that it's at 22. If you trace it well, you find out that this coincides with the what? 22nd one, okay? Now that 22nd division, you multiply by the what? by the value of one division. So that means 22 times 0.01 millimeter will give you what? 22 times 0.01 millimeter will give us what? 0.22 what? Millimeter. So that means the reading on this case, this Venus scale is what? 0.22 what? Millimeter. Now let's look at main scale. If you see main scale, the first one there is 0. Can you see it? If you trace it now, we have 0, 1, 2, 3. It stops at where? 3. 3 what? Millimeter. So now you add on the main scale, you got 3 millimeter. On the Venus scale, you got what? 0.22 what? Millimeter. So the reading of this micrometer screw gauge is simply what? 3 meter plus what? 0.22 meter. Sorry, 3 millimeter plus 0.22 what? Millimeter. And that will give you what? 3.22 millimeter. So the reading of this micrometer screw gauge is what? 3.22 what? Millimeter. 3.22 what? Millimeter. Any question? Any question? Any confusion? I should come again. Wow. Okay, where do you have issues? Let me know where to start from. Where exactly did you? Okay, what did you understand and where did you not understand? Let's start from where you understood first. So we can have a direction, because I can't continue what I said.
You said that on the Venus scale, how you explained that line wishing to 20, looking up for where we have 21, 22.
Yes.
For one value of vision
0.01 millimeter.
0.01 millimeter, multiply it by 22, we have 0.22 millimeter.
On the Venus scale.
On the Venus scale. Then on the main scale, we talk about
Start from 0 and start counting. If you watch out, you have 0, 1, 2, and 3. That last one before the Venus scale starts is where it stops. So that is 3 millimeter. Remember, it's calculated in what? Millimeter. Yes. So the reading on the scale on the instrument is now what? 3 millimeter on the main scale plus what? 0.22 millimeter on the what? Venus scale. That will give you what? 3.22 millimeter. Any other question? So the answer is what? D. Let's look at number 10. Number 10 says, number 9 says, which of the following is not a vector quantity? Which of the following is not a vector quantity? A, momentum. B, force. C, velocity. D, temperature. Temperature only has what? Magnitude. Others have both magnitude and what? Direction. Number 10 says two forces, 30 Newton and 40 Newton, act at right angle to each other. Determined by scale drawing the magnitude and direction of the resultant force using a scale of 1 cm to 5 Newton. Who solved it? Did anybody solve it?
I see, but I don't use that scale.
No, it's scale you choose, not calculation. Remember I said that we have analytical method and what? Scale what? Method. So they wanted to, the person wanted to use scale method. Did it come with your compass, with your mass set? I told you to come with your mass set. Did it come with it? Nobody came with his or her own. Wow. We want to do wonder. I want us to see American wonders today. That is, been calculating, punching your calculator. You can actually use your ruler and your protractor and your compass to draw it, and they measure the angle. It will give you the same angle with the one you are doing with what? Calculator. So since we didn't come with it, that means we have to gather here. Let me show you how to do it. Maybe on your own, you can now do it on your own at home and appreciate it. Well, what did you get in your calculation? After that, we'll compare it with what you got in your. Well, what did you get in your calculation, Ada? Did another person solve it analytically by calculation? Eh? Where they stop? Okay, you got the resultant to be what? You are still having issue with direction. The direction still they flog you, Michael. Why? But to solve on the board, they are there now. What's going on?
After stopping here, like I don't know.
All right. So what do you get?
50.
50. What of the direction?
Not yet.
Not yet. And who has solved it? Miss, somebody solve it. Chinwe, did you solve it? Hey, Chinwe. Yes. Instead we send assignment, you go and copy another one. The other day you copied English language. Today you copy biology. Calm down and read what is posted now before you start copying. Eh? I hope you didn't copy the one for next tomorrow. Well, what are we doing tomorrow? Tomorrow we'll review biology. Maybe. Okay, now let's look at this. Who will I use his or her book to do it?
I use my book.
As what? You that did not copy assignment, I'll use your book. But it's okay. We'll just do a kind of. Let's gather here. It not take time. Okay? It not take time. Let's just gather here and do it. Now, watch now. Did you come in? Okay. The question says two forces, 30 Newton and 40 Newton, act at what? Right angle to what? Each other. Determined by scale drawing the magnitude and direction of the resultant force using a scale of. Now, by scale, they have already told us. They have already told us that 1 cm represent what? 5 what? Newton. So what you need to do is this. We'll now break these two vectors down to in cm. So we now use if you want, for accuracy, you can use this, measure the distance on the meter rule before you now place it. But I already have something here. So let me just go so I don't waste our time. Now watch out. If 1 cm is 5 Newton, so what it implies is that the force of 30 Newton is actually how many cm? 6 what? Cm. True or false? While the force of 40 Newton is what? 8 what? Cm. Simple. Now, with this we can start with the larger force. That is the longer, the one that repeats the higher cm, right? Which is 8. We can make it to be the base here. We can leave it as the base here. We can trace, like I said, for accuracy, you can use this. Okay, get ACM, but let me just draw straight so I don't waste time. So we can start from here. Here is what? This is millimeter. This is cm, right? Here is what? 0, right? To what? 8 cm. 0 to what? 8 cm. Now we've gotten what? Here, ACM equal to what? 40 what? Newton. Remember, you say that they are right-angled what? Right-angled what? Triangle. So make sure that they are, with this now we can trace right-angled what? Triangle. At this point, right? Good. You should somewhere there. Okay? Now with this we can now ensure that we are at the spot. So this side is what? This acting this direction. This side is what? 6 cm. So we trace what? 6 cm here. We trace what? 6 cm. We trace what? 6 cm. This thing must be to scale. It's a must. So any mistake, you will not get the answer. It must be to what? Scale. So you trace it. You start from here. You trace it to what? 6 cm and stop here. Okay? Good. This is the other what? Force acting in this direction. This is right-angled what? Triangle. Are we together? Now with this now, you can now, here is what?
6.
Here is what? 6 cm is equal to what?
30 Newton.
30 what? Newton. Okay. Now, at this junction now, whether you do it this way or you extrapolate in what? Square form, in rectangle form, any of them will give you the same thing, but I don't want to waste my time. Let me just join here to here. Let me join here and here. Did you notice anything? Here, from here to here is what? Check it well. 10 cm, right? Good. This is the what? Resultant. Here to here is what? 10 cm. This is what? 10 cm. And 10 cm is actually how many Newton? Huh? 10 Newton. 10 cm is actually how many Newton?
Newton.
1 cm is 5 Newton. So 10 is what?
50.
50 Newton. Now, if 10 cm, this is actually the what? The resultant what? Force. And it's acting towards the direction of the higher what? Force. This is the direction. Now, if you want to trace the angle, see what you do. The angle it made with this is what? This is check this angle. What is it? Check the angle. What is it? Tell me.
90.
No, from here. The angle, this the angle I'm talking about.
40.
It's not
30 what?
37.
30 what? 7. 37. So here is what? 37 degrees. So if here is 37 degrees, here is automatically what? No, you cannot 37 degrees. 60, 53. 50 what? Yeah, 90%, 53. Now, the resultant force is what? Is 50 what? Newton. If you use the Pythagoras theorem, that's what you will get. 50 what? Newton. Now the angle is what? Now, if you want to do your what is it called? Extrapolation. See what you will get. If you want to do your extrapolation, see what you will get, which is the one you call closure. Yeah. See what you will get. See what you will get. Whether you take it like this. Whether you like, turn it upside down. Take it like this. The resultant is what? Resultant. And this is the angle it makes with this, that this force is in the same direction with, which is what? 37 what? Degrees Celsius. Now use your Sokatua. At that point you stop. You simply use your Sokatua and check whether you get this 37 what? Degrees. You can use your Sokatua now. Just do it now. If you trace it, you find out that this is actually using your Sokatua. This is the angle we are looking for, right? You actually see that Sokatua. So this is, we are looking for this angle. This is opposite. This is what? Adjacent, right? So tan what? Theta is equal to. Can you never? Okay, so tan theta is equal to what? Which is what? 30 Newton over what? Over what? 40 what? Newton, which is what? 3 over what? 4. 3 of us? 3 over 4. So tan inverse of 3 over 4 is what? That is 0.7. Tan inverse of 0. Which is written as saying tan inverse of what? 0.75. What's the answer?
0.
Tan inverse of 0.75.
Approximately 7.
That's 6 point what? 599 and blah blah blah. Everything will give you approximately what?
7.
That's 7 degrees. Look at it here. So the point there is that whether you are using scale, this one is even the simplest, the easiest way of solving this. But you must work to scale. It's a must. You must work to scale. If you don't work to scale, you have what? Issue. You have what? Issue. Any question here?
This one that you normally that you do call graphical method.
Yes. Scaling. So this is what I wanted us to do in our next physical, but the question brought it, so I decided to do it here with you.
I have a question.
Ask.
Sir, this 15 Newton, is it 1 cm is to 5 Newton? Then how many
It can be.
Newton with 10 cm? Is that?
Yes. If 1 cm is 5 Newton, then 10 cm here is how many Newton? 50 Newton.
That's how they say this.
Yes. If you make a mistake, the issue with this one, if you make a mistake with the scale, with the what? With the scale, that's where you have issue. Then you not get you not going to get the same answer. Okay, you are much set on your book. Thank you.
I'm not taking the math, I can take it next time.
I don't think I need it again for now. Just hold it, unless you want me to click for you. Okay, I should put your note again for you too. All right, now let's look at the next question. The next question says, that one is simple. It says, a body of mass, mkg, rests on a plane inclined at an angle theta to the horizontal. The component of the weight of the body parallel to the plane is A, mg sine theta, B, mg cos theta, C, mg tan theta, D, mg sec theta. Is that what? A? Sin theta. Sin theta.
How many questions did you say?
11. See, that's why remember I told you that anytime I see a question like this, I like what? Tracing it. I like drawing it first before I can. Even if I know it, I don't assume. I must put it down. I must sketch it first. I must draw the vector diagram first before I can say, okay, this is what it is. So now let's look at it. The question says, a body of mass m kg rests on a plane inclined at an angle of theta to the what? This is the horizontal, right? This is the what? Horizontal. And probably it was this is the horizontal, and the plane was inclined just like this, This is the horizontal, like this, inclined like this. Maybe on the wall or your table, anything, but it's like this. The plane is like this, okay? So if that's the case now, the plane inclined at an angle theta. We don't know the angle theta. Okay? This is the plane inclined at an angle of what? Theta to the what? This is the what? Horizontal, and this is the plane. This is the angle of what? Inclination. Now the question now says the component of the weight. Now look at the body here. This is the plane. The body is resting on what? Where? On the plane. This is the body. Okay? This is the plane. This is the body. The body can be anybody. It can be Chinwe, it can be any of you. It can be stone, it can be anything. It can be human being. But the point that is resting on this what? Plane. Now, does the question say the component of the weight of the body parallel to the what? To the plane. Now look at, of course, the weights will act how? Is it like this act or downwards? The weight act where? Is it like this? Is it like the weight of the body is acting downwards? Hope you know. The weight is acting like this. Are you aware? Are you aware? This is the weight. This is the mass. When you multiply with the acceleration due to gravity, you become what? The weight, which is now equal to what? M what? G. The mass is acting downwards. So if you multiply by the G, it becomes what? Mg. Because weight is what? Weight is actually what? Mg. Is it clear? Now, once it's acting downward like this, it becomes weight, no longer mass now. It becomes mg. That's why you here will become what? Mg. Now, what they want us to resolve this now? Resolve this into horizontal and vertical what? Component. So the component now that is parallel to where? The plane, right? This is the plane, right? This is the what? Plane. This is parallel, right? To the what? Plane. Are we together? This is parallel to what? The plane. Now, but it's acting like this. So which component now is of this is parallel to this plane? That's the question they want us to answer. If you want now, you can extrapolate this. If you want, you can extrapolate this and see where it will take us. But the angle here now, is it actually 90 degrees? This angle here, is it 90 degrees? No, it's not. Hope you know. Normal reaction is like this. I'm taking us to something else, but no problem. Normal reaction is like this, okay? So now, here now, the question now asks us now, how do we now resolve this to get this? Kenafia, Febo, we are the master of this. Tell us what you think.
I didn't get the question.
How do we resolve it now? What component is parallel? Which one is parallel to it? We have already got mg here. Agreed. So what will it be? With respect to this angle now, what will it be? With respect to this angle. Mg what? Sin theta. How is this sin theta?
The effective force.
This marker is not writing well. Now let's bring this out from this place and see what we get. Let's bring this out from this place and see what we get. If you bring this out now, this one is acting like this, right? Okay, and this one is acting what? Like this, straight, like this. Okay, like this. This one is acting like this, and this is what? M what? G. This one is like this, and this one is like this. That's remember this make an angle here. Remember, there's a rectangle triangle here. Remember, and there is a theta here. So what do you think here should be? Here is this angle here. Here is opposite to here. Hope you know. Is it opposite? Huh? It's opposite to where? Here. So sin theta is what? Huh? Opposite over what? Hypotenuse. So check well. Look at this thing now. Look at this thing now. Look well. If you trace this thing now, like remember, even though we are not getting it to scale, go, but if you trace something, if you trace here now, look at it. If you trace here now, you have something like this. This angle here, this angle here, this angle here, this thing here is already 90 degrees, confirmed. Here is what? 90 what? Degrees. And here is what? Adjacent, right? If you do this in like this, if you move this in like this, what will we get? If you invert this like this, we have something like this. We have something like this. If you turn like this, we have something like this. This angle will be where? Here, right? Then this place will turn like this. This place will turn like this, right? Eba will turn. And if you turn, you have this is opposite to this angle, which is x. This side, like this. Sorry, this is opposite, which is what? mg. No, mg is actually this is like this. If we extrapolate this, resultant you want to resolve. So now let me have a better diagram now. The alternative, the resultant is what you want to resolve. So you have something like this. You have something like this. Theta, this is here. Okay. You have this. Then this one is acting here. This one is acting here. sorry, is acting, this is here, and this one is acting here. This one is acting here. Now, these two angles, this is at right angle. Okay, so this is what you are trying to resolve. And this will have, this is actually like this. I was trying to run away from normal reaction because I have not mentioned it in this class, but I think I have to do that. Now let's bring in normal reaction now. I must mention it. Let's bring in normal reaction so you can get the correct thing. I thought I could do it without it. Now look up. You can't talk of the weight without normal reaction. Normal reaction is when, if the weight of your body is here now, the exactly opposite of the weight acting upwards, okay, is the what? Normal reaction. So let me bring in normal reaction so I can resolve this very, very well. Now look at it here. We have something like this. This one is acting what? Downwards. Now, normal reaction is acting on this plane. Perpendicular is what? Is what? Perpendicular. Exactly at 90 degrees here. Exactly at what? The weight is not 90 degrees, but normal reaction is exactly at what? 90 what? Degrees. This normal reaction. And if you, it's like this. If you trace it down, we have something like this. Straight, like this. Okay? Are we together? Huh?
Yes.
So if you trace it down, you have something like this. Now with this now, this will now have, if you bring this in back, down, you have something like this. This is normal reaction, R. This is the weight, which is what? M what? G. Now, there's theta here. This is what? Theta. Now, this, we want to prove something. That this angle here is something with what? This angle here. That's what we want to prove now. If we break it down deeply into triangles, you find out that this angle here is what? Equal to this angle. But let me not go there. Let me just resolve what I want to resolve. Now, this thing now, this can be resolved into this or into what? This. If you now open this now, you have something like this. You have something like this. Then, in the other aspect of it, you have this one is there, and this one is also what? There. Now, here now, this is 90 degrees, and there's an angle here. And there's an angle here. Now, if you now, what you are looking for is what? This component. This component, what should be here. If you extrapolate this in very well, you have something like this. Now, with this now, you can now bear with me that there's, if you trace this angle from here to here is what? 90 what? Degrees. If you trace this angle from here to here is what? 90 degrees. Now from here to here is a right angle what? Triangle. Here to here is what? Right angle what? Triangle. Now, and this parallel. So here now is, if you trace this one down, you have formed a right angle triangle with this, in this form. This is normal reaction. This is normal reaction. We have this. And we also have this. Now, if you want to resolve this side, now what you now do is here. Here is theta. Here is theta. Sorry, that right angle. There's a theta here. And here we will give you here is mg. Here is mg. Now, if you watch now, you will realize that this angle, this side, when compared to whatever angle that we form here, this side is the what? This side is the what? This side is the hypotenuse of the angle from here. And if this side is what? Hypotenuse, you now realize that if you want to find here is the what? Why am I having issues with this thing? What's going on here? Okay. Yes, mg. Okay. Here is x. Okay. This is normal reaction, which is sine theta. Here is what? Opposite. Here is hypotenuse, and here is adjacent. So x over mg is equal to cos theta. S is equal to what? Mg cos what? Theta. Okay, I have resolved this. Let me draw it away so you can see. Now, we have something like this. We have something like this. We have something like this. This is the plane. Then inclination is this. inclination is this, which is what? Theta. Then we have, this is the weight acting like this, vertically downwards, vertically like this, downward, vertically. Now, normal reaction is like this, vertically from here. Now, it should form 90 degrees with this place. We have something like this. So, like this, normal reaction. Then you trace it down like this. Now, this thing you trace down now, there's something you can form here. You can form that a parallel line that cuts here. You can cut this thing there at this point. Cut this thing at this point to meet up with parallel line with the what? With the what? Normal. Parallel to what? Normal. We have something like this. Parallel to what? Normal. It's a broken line, not solid line. Parallel to what? Normal. But it should cut at this point. Now, watch out. Watch out. Watch out. Here. This line cut here. This angle here is centered with what? This angle here. Now, what will happen is this. Here is what? 90 degrees. Here is what? 90 degrees. Watch out. The angle here, here form a triangle. Here form a different triangle. Here form entirely what? Different triangle. But the angle here, from here alone to here, not including this one, is the same thing with this angle here. Now, at this point now, this is the component of the weight, which is mg. This is the mg. Mg is here. The one we want to do what? Resolve. Because that is the what? Longest side, the what? Hypotenuse. Now here, remember here is parallel. There's also angle 90 degrees here because it's what? Parallel. Just to this normal. Now with this angle 90 degrees, this one you want to resolve is the what? The hypotenuse. The resultant. This can be resolved into this component, which is the what? Component of the normal reaction. It can also be resolved into this component that take this direction. Normal reaction is like this. This one is like this. The horizontal component or the horizontal what? Component. But why normal reaction is the vertical what? Component of this mg. Now, if you resolve this mg to its horizontal component, you can call it here x. So x, this x now, this place is the what? Adjacent. Why this mg is the what? Hypotenuse. And this is the what? Opposite. Actually, x, which is the horizontal component, is equal to over what? The hypotenuse mg is what? Cos what? Theta. But normal reaction, which is r, the vertical component, r over what? Mg is equal to what? Sine what? Theta. This normal reaction is this vertical component. Why this x, this place is the what? The one on horizontal to the plane is the what? The horizontal what? Component. So if that is the case, what it implies is that this horizontal component of this mg is resolved to be what? Mg cos what? Cos what? Theta. Why normal reaction is what? Mg what? Sine what? Theta. So, but what you are looking for is this horizontal what? Component. This is what you are looking for. So this is what? X is equal to what? Mg what? Cos theta. So the answer is what? Mg cos theta, not what? Not what? Mg what? Sine theta. Am I communicating? Ada, you mentioned Mg sine theta. That's why I try to prove it. It's not Mg sine, it's what? Mg what? Cos theta. Remember I say that we have not done this. I didn't want to go into normal reaction, but it's okay. There's no problem. It's not a waste. But because whatever you talk of a weight on an inclined plane, you cannot do without normal reaction. You must mention it. But I tried to run away from it, but I ended up going back there again. So see, normal reaction is this. You must resolve, get a parallel line, draw it like this to cut off here, so we can carve out a triangle. And I said that this angle here is actually equal to what? This angle here. That this angle here is actually equal to what? This angle here. Should I prove it? Should I prove it? If you go to your mathematics, is there. It's clearly stated. But here, if you watch now, here and here and here is 180 degrees. Watch out. Here, and here is what? 180 what? Degrees. But here is what? 90. Here is what? 90. And here is what? 90. Here is what? If here is 90 and here is 90, whatever that remains here, okay, there's this proof that said in a triangle, look at this triangle now. In a triangle like this, I don't know if any of you have come across that proof. In a triangle like this, that has an angle outside. Who has come across this proof that in a triangle that has an angle outside here, that this angle is sum of this angle and this angle? Right? Good. Now look at this triangle now. Look at this triangle critically. Look at this angle. Look up. Here is 90, right? Right? And here is 90. See two opposite angles here. Can you see them? And this angle here is 90. You people have lost interest. All right, so let's but you've got what I proved there. That is what? Mg what? Cos theta, not sine theta. Is cos theta, not what? Sine theta. Okay. Did you have any quick question? Ask. Okay, why confused? You say what?
You asked for the answer. I think that you said that answer.
Okay. Why confused?
I'm not saying that what I said is right, but I'm just confused.
You are confused. Well, let me know you're confused.
My own dad, they say that it's implied as an angle to the horizontal. Okay, right now I drew this thing. After it, then just as we did, the object that is resting on the plane, and the plane is implied as an angle horizontal, yes. Then bringing it down as to do your own. The arrow down when you wrote mg is due to, I understand this because it's due to acceleration mg. It's gravity mg. So since we are told that it is the weight of the body, the component of the weight of the body parallel. So what the question is just the component, what the component is, whether cause or this. Then this thing that is colored like this now. So we now have perpendicular effect, and now have parallel effect. Then the other line brought out this one.
Okay.
Whether it's G. Then perpendicular effect, you got to have G cos theta. And parallel, you got to have sin theta.
You say you're confused. I'm trying to see where you're confused. To get where you're confused, so we can talk about it. Where exactly are you confused? Where exactly are you confused? Is it in what I wrote? What I drew on the board?
You said that the parallel effect is mg cos theta. For my own solution, here is mg sin theta.
How did you get to your mg sin theta? Can you come and do it on the board? Let's see how you got to your mg sin theta. You cannot prove it. Forget about my own now. Do your own. Let's see your own. It's an open stuff. See, do your own. Let's see. Just leave my own. Do your own here. Let's see your own. Maybe your own may be better. Do your own. Clean here. I think this is where I got just.
This is the plane now.
Use that marker. Use one. I think this one is better. Okay.
Okay, this is the plane. The one that is US MG. Wait. This is the one implying that a body of mass mkg rests on a plane implying that an angle to the horizontal.
I can't remember what. I know that it took a 6-7.
The mg is
It took a 6-7.
this is the body.
Just hang around. Don't go, please. Okay.
This is the body mkg.
Okay.
Then this thing acting the force or the effect like due to its pulling downward is due to acceleration due to gravity.
Okay.
And they say that it's parallel, which is the component of what they ask us to find. Is parallel is this is the parallel now.
Okay.
And from here now is the what we like just as, but you know
Is what? Talk now. That normal reaction now. Say it is normal reaction. I continue.
okay, but you know what I was going to say. Then the angle here now. The angle now here. This is theta and this is G plus theta. And this one is sine.
Why? Why is here G cos theta?
Okay. You know, though you say that they're not going to use that time you solve resultant force. I talked about effective force, that of parallel, and that is parallel, either parallel or horizontal. That of S sin theta, and perpendicular or vertical, which is Fs cos theta. So this now is this thing now is perpendicular and also vertical, giving us G cos theta, as we like call it the principle of resultant force. Then this one now.
I see that till today. I want to know why here is G cos theta. That's where my attention is. I want to know why here.
That is what the principle said.
Which principle said that one?
There's books that I've consulted. They normally write down that or note down that Fs as in no, I'm not physics inclined, but it is that once we are doing all these vectors or component stuff, that if it is the one the force acting perpendicular or vertically is the result is not Fs cos theta based on what you are working on, because this one is gram, so you won't put that F because that F is force. Then if this thing, the force is acting parallel or horizontal, that it is F sin theta. And I can still remember in our note, sorry sir, it's not like I'm just but
See, if you cannot tell me why wait. If you can't tell me why this is this, I don't think we have anything to discuss.
This is is other, let's say it's other projectile.
That explain why this is G cos theta. That what I want to learn from you. Why is it G cos theta? That's why I want to know.
So I'm telling you, parents, this thing, because he proved it, that was under projectile motion. Before he said then, do something like this.
Who proved it?
This master.
Then who told you that is he's right? He's correct. Yes. Can you sit down, please? I want you to see. I gave you time. I thought maybe you have something. If you have proof that is better than my own, I will take it. That's how I do. I don't believe in this is what it is. No. If you have a super proof that can counteract what I just said now, then perfectly I will adopt it. Once it makes sense to me, I will cancel this thing I did and take it. But for you to come back and start, I just tell you that this person said I don't do this to that one. Even textbook. If a textbook writes something without proof showing me how it is, I don't cram it. I don't do that. The textbook in question should be able to tell you why it's like that. True of us. That's why it's a textbook. Not whenever is this, use this one. No. We have gone beyond that. I'm not saying that you are wrong, though. I said, tell me why is what? G cos theta. That's what I've been here since for the past 5 minutes, rattling theories of the triangle on the board, trying to prove something to you. You think I was here joking? I'm doing something. I try to show you something. So I don't believe in that. Gone are those days. The level of operating now has passed that level. Where I will just see one textbook and cram it and come here and say no. You have to be able to tell me why. If you think what I prove is not in order, then tell me this should be like this. This should be like this with proof. I will just gladly follow what you say. But if you cannot say this stands correct for now until you prove it otherwise, maybe you can go back and do more research, then come up with a better proof. That's why we are scientists. I thought people what scientific what method, right? I thought it's scientific what method. You are inquisitive in doing. When somebody says something, if before you stand up to say, make sure that you have a better proof to that particular fact. Even if you are not ready that day, you can go home, look into it, then come back. Same sir, I have seen why it's G cos theta. This is why. There's no way you can, listen carefully, there's no way you can trace without going to your what? Trigonometry, geometry. There's no way you can do that. Now, that's what I was waiting for you to use to prove to me this, but you have not been able to tell me that. That's why I will not take whatever you're saying now. Until you come up with a concrete distance that shows that this thing I'm saying is wrong. That this one is correct. I will gladly take it and go my way. I'm not ashamed to take what I think. So far you can prove to me that this is what it is. Because we learn what? Every day. You know, if you watch now, I'll be trying to. I didn't know that I was like normal reaction. How many of you will know about it? That was why I was trying to boycott it, trying to look for a way to just. But at every point in time, for you to prove it, you must bring in normal reaction. It is a must. You must bring in normal reaction. It's a must. And which I brought here, see it here. And if you bring it, this is parallel. Now, another parallel line will cut all this is off. And this thing now will be a component. Look at it. A small triangle is formed here. You are looking at your phone. That's the problem now. I'm sure you saw something now. You're looking at your phone. Once this thing cuts here, a small triangle what formed where? Here, look at it. And in this triangle, here is what? 90 degrees. True of us. If here is 90 what? Degrees. And here is that component that is what? Parallel. All you have to have. Which of this now is vertical? Normal reaction is what? Vertical. Look at it. It's one that is what? Vertical. And the weight is hypotenuse, the resultant. So you have this one, horizontal here, and this normal reaction, vertical. So if you resolve this thing now to get this, remember I said that this angle and this angle are the same thing. Unless you are saying that this angle, do you know when what you are saying is in order? If this angle is not equal to this angle, maybe this angle is actually equal to where? This angle. Because if this angle becomes equal to this angle, this becomes the what? Opposite, right? And if this becomes the opposite, this becomes the what? Hypotenuse. And x over what? Mg is now equal to what? Sine what? Theta. Then x is equal to what? Mg sine what? Theta. The question now is this. That is when it will become your Mg sine theta. The question now is between this angle and this angle, which one is equal to this? Between this angle now and this angle. If this angle is equal to this angle, then it's Mg cos theta. If this angle is equal to what? This angle, then it's what? Mg sine theta. The question now is this. If this angle, how can you trace this two angle now? This one and this one, are they the same thing? That's the point. Then this one and this one, are they what? The same thing. Remember that this is a triangle. This is a bigger what? Triangle. This is a bigger triangle. And this, whatever angle that is here, plus this is what? 180 what? Degrees. True of us. Any angle here, plus un k there at the beginning. 180 what? Degrees. But this angle here and this angle here are what? The same angle. Hope you know. This one and this one are what? The same. If this one and this one are what? The same. And here is 90 degrees. This one are the same. Now, this one here, this one here, this one here, this angle here, this one and this one, this is 90. Because this one here, from here to here is what? 90. Or yeah. That means this one is also what? 90. That means 90. Then if here is 90, and here are the same thing, here and here are the same thing, then this angle here, this one, and this one, are they the same thing? This one, and this one, are they the same thing? Alternate angle, right? This one, are what? Alternate angle, right? So, and this one and this one are the same angle. Remember that this one cut this place off. And if this and this are this and this are the same angle, what will now be of this angle here? If you trace well, you see that this angle is like this one is like this one is like this. No, that is it. Remember, we want to prove that this and this are what? The same thing. See what will happen. It's getting late. I want you to go back. Okay? Go back. Actually, if I keep you here, you go late. Let me stop here. Me, I'm saying that is what? Mg what? Cos what? Theta. And you are saying that is what? Mg what? Side. I'm even helping you to prove what you could not prove. That this becomes Mg sin theta. If here, actually, if this angle, draw this triangle well. Go and make a research. Find out whether this angle here is actually equal to this one, or whether this one is actually what? Equal to what? This one. This is what we find out now. This angle here and this one, are they the same thing? If two of this angle are equal, then it's Mg cos theta. But if this one is equal to this one, it's what? Mg what? Sin theta. Because here is already right angle triangle, and here is the hypotenuse already. So if our here are the same thing, then it's what? So just find out this angle and this angle, are they what? The the same thing. So that's what you found out before you go to the streets. All right, so I think we have actually stayed. Believe you me now, by the time we enter this topic, you may look as if the time we spend here is a waste on this thing. By the time we enter this topic, you will appreciate it better. When we enter, especially friction and what have you, that's when you appreciate what we've been doing here since. I know that it may look like, what is it called? Like shibi to mesoma. And they can see, don't worry. By the time we enter this topic, Adobe and his master are disturbing me in this class. But don't worry, it's okay, I like that. By the time we enter this topic, we know whether it's me that is correct or your master that is correct. Ada, on your most serious note, go and check that in ID. Find out which of them is equal to that one. Whether this one, come close. Find out whether this one. This angle is equal to this angle. Or whether this angle is equal to this angle. This is what we find out. So if you find out, that's when you now this one. Hope you do that. Listen. Hope you do that. Here. I think I have already mentioned this, that this angle and this angle are what? The same, right? That this one and this one are what? The same. Now.
Look at this thing now. They are corresponding.
Yeah, of course, they are corresponding.
It's also corresponding.
Are they?
Yes. Look at it very well. This one now. When you shape this diagram like this, they are corresponding. These also are corresponding.
These two here?
Yes. This and this are corresponding. This another one should be corresponding. Like just like this and this now alternate.
So what are we agreeing now that is?
The angles are.
So if this angle is equal to this angle, and here is what? X. This is adjacent. And with respect to this theta now, this is what hypotenuse, and this is the opposite. So that means x over what? Mg is equal to what? Cos theta, yeah? Neniam?
S over mg. This is the opposite.
This is what? Hypotenuse.
Hypotenuse.
So x over what?
S over mg.
Mg is equal to what? Cos theta. Cos theta. That means s is equal to what? Mg cos what? Theta. And I see. I like what you're doing. You know, this is, forget. You go far. If you continue like this, you go far. I like what you're doing. I like. Since I started this teaching, I've never seen a reason think. What you are doing is I like. But what I want to correct you. That's why I allow you to prove it. I want you to prove it by yourself. That's why I say I like keeping an open mind. If my student tell me something now, I won't tell the student it's a lie. My student come and prove it. But I believe that people read, people research. I want to say because I'm a teacher, I'll close and say that no. It's even if you tell me, sir, what you are doing is rubbish, you say come and prove it that it's rubbish. If you prove that it's rubbish, I'll say it's. I will even thank you, sir. I say thank you for teaching me that I'm teaching rubbish. But once you cannot prove it, you listen to me and learn. but what you do now, are you really sure? Are you really convinced that this angle and this angle are the same thing?
Yeah, they are the same thing, but I'll still go and ask.
Just research.
Yes, but I know that they are corresponding. If they are using all these angles.
Yes, of course, you must use it here.
They are corresponding.
Of course.
But I'll still ask.
No, ask. Hold on, ask. I'll be at next class. We'll look into it. Okay? All right. Thank you very much for your attention. See you next time. God bless you.